gotten thrown out because you said whose coffee is this?
Oh, alright. It went. So, that's fine. Let's go. Oh, okay, go. Hello, my name's Dominic Spurl. This is Mike Kershaw. This is going to be quite a quick talk. We submitted it as a 20-minute talk and they've given us an hour, so you've all got a coffee break in like 25 minutes' time. This is an idea we came up with a couple of... Oh, you've been talking about for about 18 months?
Yeah, I complained about it for a long time, and then Dominic finally went and did something about it.
Where are the speakers?
Over there.
Alright, then everyone shut the hell up! Go outside if you want to talk, otherwise you can stand here and listen to me. I would recommend going outside. So, yeah, carry on.
Yeah, I came up with the idea probably about 18 months, 2 years ago, and then didn't bother doing anything with it until finally I harassed Dominic enough to actually write the code.
This is what we call the Kershaw method.
Delegation.
Yeah, so basically, we want to solve driver issues with all sorts of devices, but in this case specifically 802.11. USB devices such as this one, or all the ones that you can see kind of being used around the CTF and things like that. And we want to try and solve some problems and open up some platforms to, other platforms to Kismet and Aircrack and that sort of stuff. So, I'm Dominic Spurl. I work for Great Scott Gadgets, writing open source software and working on some hardware stuff. I'm really bad at hardware, so this project that is based on me trying to avoid hardware by writing it in software.
I'm Mike Kershaw. I do Kismet, and I work for Blackphone. There you go.
Yeah, in case anyone missed that, Mike Kershaw wrote Kismet. Loads of times people don't recognize who he is, so this is what his face looks like. The UI on $5 is, if you've ever been using Kismet and found it useful, you should give him $5.
You don't have to give me $5.
Make it rain. Okay. So, 802.11 monitor mode. This is probably more your thing, or
sure? So it requires drivers that support monitor mode, obviously. It works really well in Linux. It doesn't work really well in anything else. OS X, there's some stuff that works with USB cards. There's some ways sometimes to put the internal card in monitor mode, but Apple keeps changing that and breaking it. There's nothing really good in Android. There's some solutions on Windows. They tend to be commercial and about $900. So, how do we deal with these problems? So this led me to have a question a couple years ago about Android, which is, can you write a device driver in Java, or is that just stupid? This question is not an or. The answer is yes to both. So I did it the dumb way. You can see Android PCAP. It's in the Google Market. There's links to the Git code on the Kismet site. You can port kernel drivers to Java. The Android Java layer is basically libUSB. You just have to convert all the kernel Java function or all the kernel USB functions and do them in Java. It's frickin' terrible. I would not recommend doing this. It involves a lot of things like that. Fun things, if you want to go to the next one.
Oh, yeah, sorry.
Some fun things that you discover doing this is Wi-Fi cards do really weird shit. The 8187, for example, if anyone does hardware and is aware of the SPI protocol for inter-chip comms, the 802.11 or the 8187 drivers do spy over USB per packet. Bit high, clock high, USB write, clock low, USB write, bit low, clock high, USB write, repeat. It's insane. Timing can definitely be an issue trying to configure these things from an Android app with no extra permissions that really doesn't expect to be doing this nonsense.
And the other thing about this is, we've already got a working implementation. So it seems like a really stupid thing to go and take an existing implementation and just try and copy the whole thing, bugs and all, into another language just to run on a different system. Like, you should be able to compile the code for both or something like that, but it's the limitations of Android and various other, mostly Android.
Well, in this case I was targeting Android, but the same thing would apply to using, random cards that work great in Linux on Windows or on OS X.
So we figured we might as well leverage the fact that they all work in Linux and try and make them work for other platforms through that.
Yeah, so the problem is, doing it the dumb way doesn't scale. So that code supports the 8187 with a couple of the main tuner chips and a couple of the EEPROMs on it. It doesn't work with anything else. Anything else is going to be, 5 to 20,000 lines of code. Plus, you have to figure out how to do the firmware loading, which is another 20,000 lines of code for most of the modern cards. For every card out there and every new chipset that comes out. No thanks. I'm not doing that.
Right. And, our time's relatively expensive. So we were thinking if we could buy a little bit of hardware to fix this, then potentially that would be worth more than the time it would take to port the driver. So we found some hardware we liked, and we'll come on to that in a minute. But basically, we're going to use a piece of hardware and build an abstraction layer. So there's already a library called Lorcon. It's by Mike and Josh Wright. It's loss of radio connectivity. And what it does is abstract away the differences between those cards. So you don't have to worry about which driver you're talking to, how it works. You just say, open me an interface, give me monitor mode, something like that. And it abstracts all that away as long as you're running on Linux. So that doesn't solve our problem for Android or for Windows or anything like that. It only solves it if you want to simplify the interface to say, if you want to simplify the code inside of Kismet or Aircrack or something like that to save those programs having to worry about the differences between drivers. So this seems like a pretty good abstraction layer, and if we're going to build a new one, we may as well build it on top of that. So a lot of people are using USB devices for this, so we may as well carry on using USB. It's incredibly prolific. It's everywhere. These things are cheap. Like this was like $30. So we just decided to extend the USB interface and modify it slightly on the fly. So what we need is a USB man in the middle device to do this. And luckily I wrote one. It's called USB Proxy, and I gave a talk about it at B-Sides a couple of days ago, where I was doing things with USB mass storage like flash drives. In this case, we're doing very similar things using exactly the same library to proxy USB traffic between the two sides of our piece of hardware. And it's a C++ framework. It connects to using libUSB to a device. It uses gadget FS, which is part of the Linux kernel, to present a USB device as a file system. And then we're using this Lorcon library to attach ourselves to the Atheros chip in this case, but whatever it's abstracted. And we're going to mirror those calls across USB. So this is kind of what USB proxy looks like. This is my opportunity to pimp my own project. We just have a device on one side, a host on the other, and we can relay traffic across the middle. We can inject packets and we can remove them into the USB layer. For this project, all we're doing is that center line across the middle of the slide. We're not injecting anything. We're not filtering any packets. We're just relaying stuff backwards and forwards. And the hardware we're using is the BeagleBone Black. And I'm going to touch it and hope everything doesn't stop working. It looks like this. It is a single board computer from a company called Circuit Code, but they use the TI chip. It's kind of TI's answer to the Pi, I guess.
Yeah, it's kind of like a Raspberry Pi. It's got more capabilities in some regards. It's got less capabilities in others, but right. It's basically equivalent to a Pi. It's
about the same price, about $40. It's a bit faster. It's got some really nice features. I prefer it to the Pi. I find the Pi relatively useless for what I want to do. But the one key thing it's got that the Pi doesn't have, and that's what makes this application work, is a USB device port. So from user space Linux code on the BeagleBone, I can write a device in software, plug it into another host, and it appears as a USB device. So they use this to appear as a file system, they use it to appear as a network device and things like that. In our case, we're going to appear as our custom USB device to provide 802.11 monitor mode and things like that. And I like it because it's open source hardware. I've forgotten about that. You can go and download the schematics and the girders and stuff like that. I hadn't seen you there. I need to. There we go. And we're using Gadget FS, as I said before. All this does is it just lets us write to a file system as if they're USB endpoints. Did anyone see the USB talk yesterday by Jesse Michael and Mickey something? They were basically talking about the structure of USB. You don't really need to worry about this at all because we've written the code for you, but you've modified my slides.
I have.
We just kind of write to a file system as if it's an endpoint, so we can send data and receive data by read and write files, which means that I don't have to care about how USB works. I don't have to care about checksums and packet headers and any of that stuff. I can just go, here's some data. So on one hand, I'm talking to a radio library that gives me like raw bytes. And on the other hand, I've got a file, and I can just write those raw bytes straight to that file, and they'll appear on the USB interface at the other end. So it's actually really nice and simple. And then Lorcon's the radio library we're using, and this abstracts away anything that we'd have to care about to do with different chipsets and different devices, as long as Linux supports it, and it has monitor mode and raw frame injection and that sort of stuff. This will let us just talk to it with a common API, so we don't have to worry about, is it an Aphros chip, is it a TP-Link, is it an RTL, something.
Yeah, and it also lets us, right now all the main drivers in Linux report radio tap, but it's always possible that's going to change and whatnot. Lorcon abstracts out those headers so we can get the signal levels, and then we'll send the raw headers onto the other device, but they won't have to necessarily pay attention to it. And we even split it up so that if you're writing code to receive packets, you don't even have to care about the header format. It just tells you, skip this many bytes in, and you get the raw 802.11 packet. You don't have to care if it's PPI or Radio Tap or Prism 2 or whatever the hell.
So this is the point at which I was going to do a demo. It should be noted that it doesn't work. The word may in this sentence is incorrect. It doesn't work. But I'm going to at least show you what happens. There's some very simple settings that we can do. It turns out, actually, we're capturing the radio data, capturing the packets on the BeagleBone, and as we pull them across the BeagleBone to write them out to the file system to send them over, the code segfaults because I'm terrible at pointer arithmetic, and this morning was not the time to rewrite that bit of code. So I'm really sorry, but I can't show it packet sniffing, but I will try to show it doing something.
It's conceptually functional, it's just practically screwed up. So
alright. Wow, this projector is not entirely on the right screen, is it? Let me increase my font size for you. And yeah. Thing. Sorry. I may not be as prepared as other speakers. Oh. Alright. So, you should also note that the code doesn't exit cleanly, so I can only do this once and then I have to play around like killing things. Okay, so I just wrote a quick tool called USB man in the middle, and it's going to use our specific device proxy here. It's called device proxy.11, and the config file literally just tells it which interface to use. There's only one on this system anyway, but it just tells it use WLAN 0. So, let's hope this works. So what you can see, I'm going to wander and point. No, that's going to scroll the video, isn't it? I'm going to point with a mouse pointer. So what you can see is we opened up a USB device. It's using the Mac 802.11 driver. It's got WLAN 0. And then it's just, the host tries to set the configuration on my USB device, which doesn't do anything. And then we start sniffing packets. And here, we've sniffed a 197-byte header. Is that true?
Probably a beacon.
Okay, we've sniffed a 197-byte header with no data, which sounds like a beacon.
So, yeah, looks like a beacon.
And then we've written it to the other side, and let's see if this does anything. No, it doesn't. So what we try and do is we then copy that over to the other side to write over to the host system, and that's when the code just sort of dies and nothing happens and nothing to see here. But what we are able to do is do things like set the timeout on the device and read it back and open the WLAN 0 on capture interface, and we're like that far away. If our talk had been an hour later, we probably still wouldn't have any working code, but we would have been a little bit closer. And that's pretty much the thing we've been working on for the past, 4 hours. And we think it's kind of a fun concept, and so we want to take the opportunity to just kind of talk to people about it. We're really sorry it doesn't work yet. But we did manage to hook it up to an Android tablet. And again, if I use the mouse pointer wherever it's gone, there it is, you can see it's connected to a .11 proxy, and in the logs it's picking up stuff coming off the device. There's no way we can hook up our Android tablet to the projector to show you this working, but it's got channel hopping enabled, and it can read the functionality from the wireless device, and we can report that to Android PCAP, and then we can start capturing packets, and then we can upload them to
anything you can share to. You can upload it to CloudShark and get a live decode that way.
Or we can copy it over to a host and run Wireshark, or you can copy it to a host and throw it into Aircrack or whatever you want to do.
But another key part of this is that the same code that makes it work on Android means it'll work on Windows with a libUSB the same way the Ubertooth does. It'll work on Mac the same way that the Ubertooth does. So we've taken it from porting 10,000 lines of code per random Wi-Fi card driver to well, here you go. Yeah, the amount of code needed to talk USB on Android, and that includes all the class wrapper crap to plug into the Android PCAP GUI that I have, is 250 lines of code.
Yeah, so we've dropped to a factor. Drop by the. Let me try that sentence again. We've dropped the size of the code by a factor of 10.
More than that,
and just for this one file, and that one interface will cover anything that supports any Wi-Fi driver that's supported on Linux. So it's not just, we've got a new device and it uses less code. We've got a new device and it covers all the existing devices. And once this code works, which is really soon, once this code works, all of the supported Linux 802.11 devices will work on Android, and someone can write some libUSB code for Windows and it'll work on Windows. And it just becomes a much, much easier way to do it. And the only thing that it costs is $40 for the Beaglebone Black, if you can get hold of one. We're also looking at porting it to, the code is generic, it's written targeted to Linux. So if you find another piece of embedded hardware with a USB device port on it, it'll work for that as well. So there's an Olimex Lime, and I'm trying to remember some of the others. There are a whole bunch of different boards, and they're all in the under $50 range. And so one of them, paired with a Wi-Fi device, will enable you to use Android or Windows or OS X. And I think that's mostly our project. Just want to thank Josh Wright and Mike Lussman, because Josh Wright helped you write the Lorcon library, and Mike Lussman continues to pay me, even though I work on things that have nothing to do with making any money. So thank you, Mike Lussman.
This might be a stupid question, but
that's fine.
You have a hardware device based on Beaglebone.
I'm going to run down to you because I can't hear you.
So you got your Android device. What did you do, Beaglebone and that additional wireless card, or was that